In this topic, we'll look at outer joins, one of the most powerful SQL features. In prior lectures, we looked at rewriting nested queries as joins. For instance, here up at the top of the screen is a query on Bakery 4 to find all products that have been on discount. You can see it just selects products where the ID exists in a list of discounted products. Now, that query is easily rewritable as this one here, joining product discount and looking for IDs from that join. But a not exists test is harder to translate to a join. How do we rephrase the following query, which finds products that have not been on discount as a join? We can't just join product to discount X product, because the query wants cases where there is no discount X product row to join with the product row. Such cases won't even appear in the join result. This situation, where you want to test if a join will fail, is so common that SQL provides a special type of join for it, called an outer join. This type of join comes in several variants, including a right outer join, a full outer join, and a left outer join. We'll discuss all the variants later, but 99% of outer joins in practice are left outer joins, so we'll look mostly at those. A left outer join between tables A and B works just like an ordinary join if a given row R in the first table A has at least one partner row, per the join condition, in table B. But if there is no such partner row, then the left outer join, instead of simply dropping R from the join for lack of a partner row, creates a table B row comprised entirely of null values and matches it to R, even though of course it wouldn't really fulfill the join condition since null doesn't match with anything. This null value row isn't actually added to table B, it's just temporarily created as a partner of last resort for any rows from table A that don't have real partners in B. And this applies only to table B. The left outer join does not make up null value A rows for B rows that lack an A partner. So let's try it here on product and discount by product. Select star from product, left outer join, discount X product on ID equal product ID. The syntax left outer join, or just left join from now on, you can leave the outer out, performs a left outer join from product to discount X product. The output illustrates the outer join concept. Every product lacking a discount X product partner row instead gets an all nulls partner row. Again, this row is not actually added to discount X product. It's in effect a big no match found flag, which can be used in where clauses to find absent matches in a join. So our not exists query from above can be rewritten as select ID from product, left join discount product on product ID equals ID, where product ID is null. This uses the left outer join we just did, but it filters for a null product ID. So it lists only IDs from products that don't have a discount X product partner row. And if we run it, we get the same output as for the earlier version that used a not exists with its 33 rows there. Now, which approach is better? As we mentioned in an earlier lecture, this depends on who you talk to. The short version is that outer joins are generally faster, but that at least beginners find nested queries easier to read. In practice, you need to understand both, and indeed our exercises and test questions will often ask you to translate between the two forms. Okay, so now try one of your own. List ID for all products that have never been purchased. Try it both with a nested or subquery and with a left outer join. And a reasonable answer here would be, first for the subquery, select ID from product where not exists, select star from line item, where product ID equals ID. And then the left join version, select ID from product P left join line item on the appropriate join condition and checking for product ID is null. The subquery version checks for products with no corresponding line item. So does the left join version, by causing an all nulls line item to be joined with any product lacking a real line item partner row. Each query returns the same result, as you can see. Evidently, no one likes chocolate cake, which is what that is. Okay, question 2. Try listing first and last name for all customers who have purchased nothing, those who have no receipts. Don't bother with a nested query solution this time, just do the left outer join solution. You should get a query about as simple as the prior ones. So one reasonable solution would be select first name, last name from customer, C, left join receipt on the appropriate join where customer ID is null. So we had a null valued receipt. And this follows the same principles as the others. It's matching a customer with an all nulls receipt if there are no other receipts, and then tests for null customer ID. And it looks like Joe Cheap is the only one. Okay, now let's try something a bit more subtle. I'd like to know which, if any, discounts did not include a chocolate-flavored product. Write a nested query select for this, giving the ID of all such discounts. So what we need to do is check for discounts for which there is no linked product through discount X product of chocolate flavor. So select ID from discount where it not exists, select star for chocolate flavors, and it looks like there are 2 such discounts, IDs 4 and 5. Okay, now let's try it via a left outer join. And this is a little harder than the prior examples because there are so many joins involved. Maybe we should just make them all left outer joins and do it like that. Select DID from discount D, left join discount product on discount ID match, left join product on the appropriate match, and then check for flavor, and the PID is null. Well, unfortunately, it's not so good. It returns an empty set, as you can see. So why is that? Seems like what we're doing is hunting for a discount with a chocolate product and then checking for the failure of such a hunt via p.id is null. We know there are discounts where that check will fail, so why the empty set? Well, let's debug this thing, one outer join or one left outer join at a time. We'll get some reinforcement on outer join concepts by doing so, and we'll learn a bit about debugging outer join queries. So, question that I'll show from the notes here, what effect, if any, does this first left outer join have? What difference is there between the queries discount join discount X product and discount left join discount X product? And the answer here, of course, is pretty direct. A productless, or if discount has no product at all associated with it, then the left outer join will make up a null discount X product to link to it. Otherwise, the two do the same thing. Now, a productless discount certainly meets our criteria for a no chocolate discount. So having a null row linked to it as a no match indication sounds good. And once the discount X product is null, then the left join with product will also produce null. And the p.id as null check will pass. So that first left join correctly catches productless discounts. The only reason we don't see those in the output is that we don't have any productless discounts in the current database. They all have at least one product. We still need to deal with discounts that do have products, but no chocolate ones. So, same question now as for the prior left outer join. For the next one, again from the notes, what is the difference between these two joins if the discount X product row is a normal row, not a null row? And the answer, as you can read in the notes, is that a normal discount X product row always has a matching product row due to foreign key constraint. So the two queries don't produce a different result for a normal discount X product row. Nothing in the query here says fail to match with a product row unless it's chocolate. Okay then, so after all this analysis, what does the proposed faulty left join query that we did earlier, what does it do for cases where a discount does cover chocolate products and for cases where it does not? And what does it take to get p.id to be null? Well, summarizing all of this, For a discount with no products at all, p.id is null will be true, but there aren't any such discounts in our database, and besides, the null flavor that resulted wouldn't be chocolate, so we'd still get an empty set in the entire query. For any discount with some products, the left joins will not produce null rows. So whether the discount covers chocolate or not, p.id will not be null, and we get no rows. So this query won't cut it, but it's bad for subtle reasons that are only clear if you reason through each left outer join. Just throwing a lot of left outer joins around isn't the solution for problems like this that go across multiple tables. So then what is the solution? Well, if you think about it, what we really seek is a discount with no matching combined discount X product join product whose flavor is chocolate. So what if we first join product to discount X product with an ordinary or inner join, that's the type we've been using up till this lecture, to get those chocolate combinations. We'll use both a foreign key primary key match and the chocolate requirement in order to filter the joined rows to just chocolate flavored ones. And do recall that the on condition in a join may be more than just a pk equals fk check. So we're proposing this: product p join discount X product on ID equals product ID and flavor equals chocolate. And that's going to produce only chocolate rows. And then we'll add a left outer join with discount so that any discount without a chocolate row match gets a null row. Let's try it out. And it's almost right. But if you run it, as we did here, you can see that we still get another empty set. Evidently, p.id is still never null. Which leads to question 7. So if there are no chocolate product join discount rows that match a given discount, won't we get a null valued product join discount row making PID null? What's wrong with that assumption? The answer here is that if there's no match, it is the right-hand side, the discount, that gets a made-up null row. A left outer join respects the left table and will make up null rows only for the right table. So we're not going to get a null value for p.id out of this left join. What we need is an outer join that respects the right table and is willing to make up null value rows for the left table. And such a join exists and is, unsurprisingly, called a right outer join. And you can probably guess the MySQL syntax for it. Select d.id from product p, same joins we had before, except that it's now a right join. And, as you can see, finally, this works just like the nested query we started with, giving IDs 4 and 5. Now, right outer joins are not strictly necessary. One can always switch the order of the two tables and then use a left join instead. But it's often prettier to use the right join. As an example, rewrite this successful query that we just designed with a left outer join instead of a right outer join. And you may use an inner view if you need to. You're going to need to swap the two joined quantities here. So the answer here is that you need to use an inner view to group the product join discount product as a single table. And then I labeled it as CP, you can see, and then we did a left join on discount with that. And this works now, but it's a little more awkward than the right outer join solution for this particular problem. And to be very complete, by the way, while MySQL doesn't actually offer it, there is a full outer join offered by some SQL implementations, and that creates null rows for both left and right tables as needed. In the next segment, we'll do some more outer join examples.